Welcome to this video on WellCAD 6.0. As the new Geomechanics workspace is a major part of this release, to start the Geomechanics workspace, click on this icon and the workspace opens. It allows you to select the different kinds of parameters that can be generated, and here is the complete list. The user can also select the depth reference, air gap, borehole type, and even use predefined zonations. For this example, we enter an air gap of 50 meters. We select OK, and a new Geomechanics workspace is going to be created. The Geomechanics workspace will have a log space, a navigation view with the Geomechanics Explorer bar displaying the logs in the log view. The first thing we need to do is to bring in the relevant logs into the workspace that are needed for the calculation, and these are the Poisson dynamics and the Young's modulus. We select the DTCO, gamma ray, DTSM, and the lithology logs and drag it to the Geomechanics workspace. We can then configure the log space by rearranging the logs. In the navigation bar, we can see a few of the logs, and in blue it shows the depth range of the log space. We can see that the Geomechanics workspace is structured with the Explorer bar on the left and the navigation bar next to it. Icons here allow us to select the new parameters, and we can import logs, we can export logs, we can open the more column diagram and the stress bar. We'll come to that later. The user can also start the process by selecting a zonation in one of the parameter logs. We can start with a zonation from top to bottom, but may want it to be more precise. You can just click the Shift key and press the mouse button and create a zonation. Now that we have selected a specific selection, on the right hand side in the properties bar, we can select the method that we want to use. In this case, by default, the default method for dynamic Poisson ratio is the slowness method. This method requires P slowness and S slowness as input. The user may want to change the specific method that is assigned and can open a library of different processes separated by different types of lithologies. We can now come back and assign logs to the P slowness and S slowness, and in this case we can use the compressional sonic and the shear sonic respectively to generate the output that we see here. We can continue with this and other zonations until we're satisfied with the final results. In this case, we have 3 different zonations, and the user may want to go to a higher level of details. We can also use the lithology log for zonation by clicking the right button and selecting Copy From. WellCAD will calculate the Poisson ratio values for each of these zonations and can use different kind of calculations for each zonation. For example, in this case, if the user does not want to use the slowness method, they can simply click on the zone and change the method. For example, if they want to use the Abbas method, they can go here and simply select it. WellCAD will display the type of method that's being used in each zone. The process can continue for additional parameters or properties. In this case, we can see an example where different mechanical properties have been completed, such as Poisson ratio, Young's modulus, UCS, etc. We can also see that calibration with core measurements have been performed. Here the data is displayed as dots. The results can be exported to the borehole account by clicking on the Export button. We can also see that calibration with core measurements have been performed. Here the data is displayed as dots. The results can be exported to the borehole account by clicking on the Export button. And now we can see the results in the borehole view. In the case where users are not satisfied with the offered methods, they can create custom equations using the Custom Equation Editor. In the Custom Equation Editor, the user can bring specific equations from different sources. In this case, an equation from a publication can be used and added to the parameter list. This is for the rock mechanics section. Let's move on to the stress calculations. The geomechanics workspace can calculate hydrostatic pressure, overburden pressure, pore pressure, SH-min and SH-max. The user will want to select a new workspace and the desired output parameters, and the workflow will be the same as for the rock mechanic properties. The first calculation will be for the hydrostatic pressure, then followed by the calculation for overburden pressure using the previously calculated density estimation along the well bore. For the pore pressure, the Eaton equation has been selected. We can use an interactive process in which the user needs to determine the clay and non-clay intervals. We need to construct the normal compaction trend, and then we get the pore pressure. And finally, we calculate the SH-min and SH-max. When the user is satisfied with the end result of the geomechanics workspace, the output can also be exported to the borehole document. Another thing that the user can do as well is to get an understanding of the fracture stability and criticality corresponding to the specific picks that have been previously defined in an image log. In this specific example, we have data from an FMI where different picks have been interpreted. WellCAD can also deliver fracture stability on the picks that are seen here. So a new workspace has been created for the Mohr-Coulomb diagram with the stress bar displayed. Now we can analyze the different fractures that have been interpreted. We can see that there are fractures displayed above the envelope of the Mohr-Coulomb diagram, indicating these fractures may slip. These picks and fractures displayed in green indicate that they are stable. In WellCAD 6.0, we have two new chart plots, the box plot and the spider plot, as you can see here. Another important development is the possibility of adding a new reporting console in the automation module. We can deploy the script editor by going to View, Toolbars, and select the script editor. We now have this section at the bottom of your screen. When we open a script and run it, WellCAD will now show exactly what is happening. In this case, we enter a loop as per the script and it tells us exactly what it's doing. It is very useful for fixing bugs in the script. There is also a new feature incorporated in the header editor that deploys the new box plots and spider plots. You can see here the visualization of the gamma ray. One can also define depth intervals for these plots, and in this case from 3,350 meters to 3,400 meters. Another feature is the handling of data imported to WellCAD. Here we drag and drop a new LAS file. We now have this dialog box where we can resize the column widths. This is particularly important when we have a large file with multiple columns. A great new feature is the preservation of the bitmap ratio of images. For example, when we export this image as an annotation, and then choose to resize it, it keeps the bitmap ratio and not distorted as before. Another enhancement relates to the strata log display. We can insert a new strata log in WellCat. First, we add a new dictionary and add a few new entries. And now it is possible to display different labels, code, or even the description, or both. Another functionality is related to the borehole page settings. You can go to File, Page Setup, and a new dialog box has been added. The user can select the print range from a log in WellCat, example the core box log. Lineations also can be displayed in the 3D log in WellCat 6.0. First, add a new lineation log, and then add some interpretation in the image log by clicking the Shift key on the keyboard and using the mouse. Let's say we add one here, while actually there is nothing. Then we select the 3D log properties and we go to the lineation compound in the data display. We select the log and the attributes, and then it can be displayed in the 3D log. Now this is applicable to lithologs, core description logs, marker logs, and every log with a dictionary. In the past, when the code of a specific dictionary was modified, the code was not immediately updated in the data table, and basically the interpretation was lost. So in this example, with this litholog, we open the dictionary. We can change the code, for example, to number 1 before code in the data log, remaining the same, and now we can see the data has been updated, even when changing the code in the dictionary. Another example is when you are changing the name of the entry. In this case, from sand to sandy, it is now automatically updated. Another new feature is the addition of new bedding context styles. When we open the bedding context dictionary, we can see all these available contexts. At the bottom of the list, we can see there are a total of 11 context styles. In addition, another important feature corresponds to the partial pix visualization. In this case, we see that there are a number of partial pix. The extension of them are displayed by these dashed lines, where the fractures do not occur. There is a way to toggle the dashed line on and off by going to this option and select No. And then the dashed lines disappear. There is a possibility to visualize statistical data corresponding to the selected log, which can be found in the status bar at the bottom right-hand side. Basically, if you want to understand more about the corresponding statistical data, for example, the porosity, check the lower part of the display, and what you will see is the top and bottom depths of the log, the number of data points, the minimum and maximum values, and the sampling rate. Another new feature corresponds to the header editor. It is now possible to drag and drop any type of metadata from the metadata bar into the header. So let's say we want to bring in the date. We just have to drag and drop it into the header. A new process has been added to calculate relative lengths of each fractures that has been added. And this is a new process in the Easy module. Go to Structure, Logs, Fracture Length Estimation. You can select the type of fractures that you want to select for the estimation. You can also select a depth range if necessary. If you do so, we select OK, and we have a new track for the length ratio that's being displayed as a mud log type of curve. Another useful feature is the one that controls the visualization of the nodes. In a structure log, we go to Properties and the node selection and select Display Yes or No. The default setting of the nodes can be controlled going to Tools, Options, Log, Structural Log, and now we have this option to display nodes as a default or not. In the past, when there are many nodes, WellCAD was choked by the number of nodes. But now we have this display option deactivated. The nodes will not be displayed, saving a lot of memory, speeding up WellCAD. Another important functionality that has been added to the Easy module in the polar chart crossplot is a dashboard for the dip picking interpretation. You can now draw clusters such as this one. Clusters can be created by using the Shift key on the keyboard and creating a cluster area. Cluster statistics are displayed in the lower left corner and can be copied and pasted in Excel, etc., or they can be exported as an ASCII file. Another useful addition of picking fractures has been developed. It is now possible to move the sinusoids downwards. Before, to fit a sinusoid, the only way to move was upward. Now the feature can be moved downwards as well. One more addition to the basic feature is in the formula log. Let's say if we wanted to make a new formula, let's say 2 plus the dt, but called it a DTO, which is a log that doesn't exist in our suite of logs, we will get a message that highlights the syntax error in the formula field. Once recognized, then it can be immediately corrected. These are the highlights of WellCAD 6.0. Thank you for watching.